Now let's assume that we have to find the phase of a system and pressure and specific volume is given. Now we can use the given pressure to find Vf and Vg values. So we will go to saturated property tables and find Vf, Vg values. And then we are going to compare our specific volume, the given specific volume, with the saturated specific volumes for liquid and gas. If our specific volume is same as saturated liquid specific volume, we can say that the system is a saturated liquid. If it is same as saturated vapor specific volume, it is a saturated vapor system. If the given specific volume is falling in between Vf, Vg values, it is a saturated mixture. And if given specific volume is lower than Vf value, it is a compressed liquid. And if it is higher than Vg value, it is a superheated vapor system. Now please remember, specific volume here can be replaced with internal energy, enthalpy or entropy, and we can use the same procedure to decide the phase of a system when those properties are given. Enthalpy and entropy are two topics that we have not covered yet. We will be covering those specific properties later in this course. Now, instead of pressure, if we are given temperature and specific volume, we can use the same procedure to find the phase of the system. The only difference is we have to go to saturated property tables but temperature table. Now let's assume that we are given temperature and pressure, and we have to decide what is the state of the system. We can select one of them, let's say pressure, and we can find what is the saturation temperature for that pressure. So we will go to saturated property tables, pressure tables, and we will find saturation temperature for the given pressure. And we will draw that on our PV diagram. And then we will take the given temperature and we will compare it with saturation temperature. If the given temperature is higher than saturation temperature, let's call it as TA. Our TA line will be going above the saturation temperature line. Now we know that our system should be on the point where given pressure and given temperature intersect. So in this case, we can see our system is in superheated region. If the given temperature is lower than T saturation, TB line would be going below the T saturation line, and we will see that the intersect between given temperature and given pressure is going to be in the compressed liquid region. We can follow the same procedure for a TV diagram if we decided to use temperature instead of pressure. When temperature and pressure is given, and when we look up for saturation pressure or saturation temperature, if that value is equal to the given pressure or temperature, that means we are in saturated region.